Hello everyone, this is Wilson here. Today I want to talk about this limit problem here where we have a sine of 3x and a sine of 5x. And as you can see here, if you plug in the 0 into all the x's, you are still going to be getting 0, and then that's also 0, and then at the bottom is going to be 0 minus 0. So we're actually having an indeterminate form of 0 over 0. So how do we handle this limit? What we need is that first, that's really important, is that we need to recall a fact, which is that when we take the limit as theta approaching 0, sine of theta over theta is approaching 1. Okay, so now you can see that this is the function where we have the sine, and then we have the same quantity as whatever that's inside the sine. So it's the theta here, and then also we have a theta at the bottom. And this theta is approaching 0, and this function will be approaching 1. So we are going to manipulate our limit into this form so that we can use this fact to help us find this limit. Okay, so let's get started for the limit problem. So first, we are going to break this product into two fractions at the beginning, right? And then you may say, what about the denominator here? The denominator, we can just put it aside, right? We don't need to worry about it at this point. So what we are going to do at the beginning is that first we are going to write it as sine of, let me rewrite it. So we are going to be getting sine of 3x, okay? And then because that's in the numerator, so in the denominator, we can just leave it as a 1. Okay, times. Now, what about the other factor? The other factor is the sine of 5x, right? So we also write it like how we wrote the sine of 3x. And so we are having sine, let me get more space here, sine of 5x. Okay, and then we are going to get the 1 here. And then times. Okay, so now we also need to write down the denominator, right? So this time we have 1 over, okay, 1 over the x to the fourth minus 2x to the second. So just this. Okay, so this sine of 3x times sine of 5x, which will give you the original numerator. And then this 1 times x to the fourth minus 2x squared will give you the original denominator. Okay, so now what we want to do right here is that we know that x is approaching 0. And so when x is approaching 0, that means 3x is also approaching 0. 5x is also approaching 0, then we should be able to use this fact right here. But one thing that we need to do first is that we need to make sure that whatever that you have at the bottom, right, this is theta, must also be the same as whatever that's inside the sine function. Now, inside this sine function right here, we have a 3x. And instead of having a 1 here, we actually need to have the same thing as what we have for the sine, for inside the sine function, right? So we also need to have a 3x at the bottom. So how do we get the 3x at the bottom? We need to put a 3x at the bottom. So that means we're going to be doing multiply the bottom by the 3x. Then you may say, isn't that changing the problem? Then that means we also need to multiply the top, right? The numerator also by the 3x. And so let me extend this fraction line right here. So see that we are not changing the problem because we are just multiplying by 1 for this one, right? The original expression is sine of 3x over 1. Because I want a 3x at the bottom, so I multiply the bottom by the 3x, and then I also need to multiply the top by the 3x. And then now same situation right here, we need to multiply the bottom by the 5x, right? And then we are going to multiply the top by the 5x. Is that okay so far? Now, Um, Maybe this one we need to do something to it, but we'll worry about it later. But at this point here, as you can see, the limit of sine of 3x over 3x, as you can see here, that's equal to 1, right? So the limit is equal to 1. So we can actually turn this expression into a 1, and then we can also turn that expression into a 1. And so basically what happens is that we are actually getting this now. We're actually getting the sine of 3x, okay? And then all over. So let's just put everything together for now. Then we have the 3x, okay? So which is coming from this sine of 3x over the 3x. I put it here. Then times. And then we have the sine of 5x over the 5x. Okay, now, so as you can see that I actually left out the 3x and the 5x, I'm going to put it on top of this fraction. So we are going to be getting, let's just multiply them together. We have 3 times 5, and then x times x. We are getting 15x squared. Okay, so we are getting 15x squared in the numerator. And then what about the denominator? We can just copy, but I actually want to factor out the greatest common factor. Okay, so let's factor out the x squared from those two terms, right? So we are getting x squared, and then we have x squared minus, what is that? That's going to be 2. So now our limit problem looks like this. Okay, so what do you see here? We actually get an x square here, we get an x square here. You see what we can do? We can actually cancel them out. So we get cancel out the x square, cancel out the x square. And then now you're left with just 15 over x squared minus 2. And just plan a little bit ahead. If you plug in the 0 into this x right here, you are not going to be getting a indeterminate form. It's actually just becoming negative 2 at the bottom, and then the top is 15. And so you know that this is becoming 1, that's also becoming 1 because we're using this limit result right here. So what are we getting here? Eventually we are getting 1, right, times. So that's giving us the 1, and this also is giving us the 1, right? Let me use the same color as you can see here. So that's becoming the 1, and then the other one is also becoming the 1. And then the last one is when you plug the 0 directly into this x squared. So we are getting 15, and then we have the square minus 2. Okay, so we plug the 0 in here. Okay, we plug the 0 in here, and then you are getting this. And now cleaning up the expression, we actually will have the limit for this problem. So we have 15 at the top, we have negative 2 at the bottom, so we are actually just getting negative 15 over 2. And then we're finished. Okay, so that's it for this problem. If you like this video, please give me a like, subscribe to my channel, and share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment. Thank you for watching this video. I will